Assume that an IT specialist's marginal profit function is 400 minus 2x, where x is the number of units sold. Given that the IT specialist breaks even on sales of 10 units, find the fixed costs the IT specialist is likely to incur. Okay, so let me just give you first context about this question, right? When you hear this term marginal profit, okay, marginal just means addition. Okay, so marginal profit, this is the extra profit you get when you sell one more unit. Okay, marginal profit is the extra profit or the additional profit you get from selling one more unit. Okay, so if this IT specialist sells one unit, this is the extra profit he's getting. Okay, 400 minus 2x. Okay, this is the extra profit he's getting. He sells one unit. Alright. Now here we are trying to find the fixed costs that this person is going to incur. Alright. And they've even given us information about break even. So another important point to remember, marginal profit is the derivative of profit. Okay, meaning when you derive the profit function, you are supposed to get the marginal profit function. Okay, colleagues, when you derive the profit function, you're supposed to get the marginal profit function. Okay, now here we have to work backwards. We have to integrate the marginal profit function to get the profit function. Colleagues, in calculus, differentiation and integration work hand in hand. Okay, differentiation moves forward, integration moves backward. Let me just illustrate what I mean so that we don't get confused. Okay, let me just show the rules for both of them. For differentiation, this is the rule. Okay. If you are deriving a to the power x, right, you always have to multiply the exponent, which is x. Okay. This is not part of the question. I want to illustrate how differentiation and integration are attached, how they are related. Okay, this is differentiation. This is the power rule for differentiation. Okay, and I'm going to show it in I'm going to illustrate it. Okay, then for integration, right, this is the power rule for integration. So let me show you how these things are related. Okay, so for example, you can have let's say x squared, and they tell you derive x squared. Using the power rule to derive x squared, multiply the exponent with the number in front of the letter. 2 times 1, that is 2 x. Then you subtract a 1 from the exponent. Okay, you get 2x to the power 1. Okay, 2x to the power 1. Now we can integrate this 2x to the power 1 to come back to x squared here. Okay, if we integrate 2x to the power 1, it's going to be like this, 2x. With integration, the power you add a 1. Okay, so you have 1 plus 1 over what you do on top with the power here, you do at the bottom, over 1 plus 1 plus c. Okay, x plus 1 plus 2x squared. Okay, 1 plus 1, that is 2. Okay, we cancel out the 2's, we get an x squared. What we started with this x squared, we are back to this x squared. Okay, plus c. Okay, so differentiation moves forward, then integration moves backward. Any questions so far? So what does the c mean? The c means a constant. Okay, for example, if we had x squared plus 1, and they tell you derive x squared plus 1. When you derive this, remember, multiply the power with the number in front of the letter, you're going to get 2x to the power 1. Then this 1 which hasn't got any letter, it disappears. Okay, it disappears. Okay, so if we derive x squared plus 1, our answer is 2x. The 1 has disappeared because when you're deriving, a number without a letter goes away. Okay, so when you work back with integration, okay, when you work back with integration, this c is representing any constant, any number that doesn't have a letter attached to it. Okay, so this x squared plus c is the same as this x squared plus 1. This c represents this 1. Colleagues, are we okay with that, or are we even more confused with what's happening here? Madam Mabel, is that with you? Madam Sarah? Madam Shirley?
What's the question, sir? I had to log out. The network was tripping.
Have you seen how differentiation and integration are interrelated?
Oh, yes.
Differentiation moves forward, integration moves backwards. Okay? So now let's apply this to the equation that we are doing here. Okay? Let's apply it to the equation we are doing here. Okay, because we need to integrate our marginal profit to get our profit function. Okay, colleagues? The equation has given us the marginal profit, but us want the profit. So since we know the marginal profit is the derivative of the profit, so then the profit, to get it, we have to just integrate, we have to move backwards. Okay? So we need to integrate this 400 minus 2x. Okay? So first things first, we need to integrate 400 minus 2x. Okay. So with integration, remember with differentiation, if a number doesn't have a letter, it disappears. Okay. With integration, if a number doesn't have a letter, okay, this is how the letter comes to the number. We're going to have 400 x to the power 0. Now you might be wondering, where is this x to the power 0 coming from? Colleagues, anything to the power 0 is the same as 1. That's why if you are deriving, let's say, a number like 2, okay, if they tell you derive this 2, it has to disappear. How it disappears? Because you assume there's an x to the power 0 here. So 0 times 2, that is 0. 0 minus 1, that is negative 1. You get a 0 over x, which becomes 0. That's how a number without a letter disappears with differentiation. Now in integration, a number without a letter, the letter will eventually come back to that number. Okay? So, minus 2 x to the power 1. So we apply this rule for integration, okay? Add a 1 to the exponent, so you say 0 plus 1. Even here, add a 1 to this exponent. Okay, and remember also put a plus c, because when you're integrating, you're always putting a constant. Okay. Yes. So this will be over 0 plus 1 over 1 plus 2. Okay, as you can see with integration, after you add the 1 to the exponent, you do the same thing at the denominator. Okay. So 0 plus 1, that is 1. So we're going to have 400 x to the power 1 over 1 minus 2. Here is 1 plus 1, not 1 plus 2.
I even wanted to ask to say, where is that 2 coming from?
Okay. It shows you are following. Wonderful. Yeah, it's 1 plus 1 there. Okay, so get 2x squared over 2 plus c. Okay. 1 divided by 400x, you're going to get 400x minus 2 divided by 2, that is 1. So you have 400 minus 400x minus x squared plus c. Okay. This is the profit function. Okay. This is the profit function. Okay. And if you're asked to derive the profit function, you say 400x to the power 1. Let me just show you that it comes back to the marginal profit function. Okay. So if we had to derive this profit function, okay, 400x minus x squared. If we had to derive this, remember deriving this is 400x to the power 1. Okay, multiply 1 by the number in front of the letter 1 times 400, that is 400. You always subtract a 1 from the exponent, that is 0. So you have 400x to the power 0. Okay. Minus, when we derive x squared, you're going to say 2 times 1, that is 2x. Then you subtract a 1 from the exponent, 2 minus 1, that is 1. Now remember, x to the power 0 is the same as 1. So you can just write this as 400 minus 2x. Okay, this constant would have disappeared when we're deriving this. Okay, the constant disappears. Okay, any questions, colleagues, before we move further? Okay, this is actual Greek. These symbols are Greek. Okay, so if you say, in that today's class I was just hearing Greek, yes, we're using Greek symbols. Alright, so we have our profit function. Then in the question, they are telling us this. Okay? Given that the IT specialist breaks even on sales of 10 units, right? So he breaks even when he sells 10 units. So remember, at break even, colleagues, what is your profit? When you break even, what is your profit? Mr. Define?
The profit is zero. There's no profit.
There is no profit.
Just to change what you put in.
Yes. So this profit, at break even, this profit function equals 0. Okay. At break even, profit equals 0. Okay, so we're going to have our profit function here, 400x minus x squared plus c equals 0. Alright, and they told us he breaks even when he sells 10 units. Remember, x represents the number of units. X equals 10. Okay, he breaks even when he sells 10 units. Okay, so we're going to substitute x equals 10 into the profit function there. Right, we're going to have 400, substitute x with 10, minus x squared plus c equals 0. So 400 times 10, that is 4,000. 10 squared, that is 100, plus c equals 0. Yes, was there a question? Okay, so we have to find the value of c. 4,000 minus 100, that is 3,900, plus c equals 0. So the value of c is going to equal to this 3,900. You take it over this side, and it becomes 0 minus 3,900. Therefore, you're going to say c equals negative 3,900. that is the value we're looking for here in the question here. Find the fixed costs the specialist is likely to incur. Okay. So C equals 3,900.